All right, so we're going to do the same thing with number 11. We're going to label the information in the question, label our givens, determine our unknown, and then pick an equation. And then so let's read the question. It says, a car driving down a mountain started from rest and achieved a velocity of 61 meters per second with an acceleration of 2.5 meters per second squared in 24.4 seconds. How far did the car travel? So there's a bunch of information here, but let's go ahead and figure out what we can label. So if I just look at the numbers, I'm going to see 61 meters per second. And I do know it's a velocity, and it happens to be a final velocity. And if you read that, this is the velocity the car is going at the end. Your initial velocity would be the starting velocity, and I don't see a number for that. However, if you see words like this, started from rest, that is a piece of given information. It's not a number, but if you see the words at rest or if you see the words comes to a stop, then you should know that that means that your velocity at that point in time is 0. And this is starting from rest, so this is the initial velocity. VI is 0. So there's VI and VF. My eye looks a little weird. That's okay. All right, other pieces of information. Acceleration is 2.5 meters per second squared. It was nice and it labeled it for me. But again, if it doesn't say that, you should still recognize based on the unit that that's an acceleration. Meters per second squared is an acceleration unit. We're also given a time. So let's go ahead and label our time. And that is 24.4 seconds. So I've got quite a bit of information here. How far did the car travel? My unknown. Again, I'm actually looking for the same thing I was in the last question, delta x. So I actually have VI, VF, A, and T, and I'm looking for delta x. So if I go back up to my equations, that's everything. Okay, now, again, because I'm looking for delta x, I'm not going to want to use this equation. It doesn't have delta x in it. I can't solve my question with that equation. But I could use any of the other equations because I know all of the other variables. I know VI, I know VF, I know A, and I know T. And so it's really up to us which one we want to use. The ones that are already set up to solve for delta x will be easier because we don't have to rearrange those. And this last one is probably the easiest whenever you're comparing the two because it doesn't have all the stuff that this one does over here. So let's go ahead and use that. Delta x equals VI plus VF divided by 2 times T. So that's the equation I'm going to plug into. You'll notice that this equation doesn't have acceleration in it, and that's okay. I don't have to use the acceleration. Okay, so I can solve it without it. So it's an extra piece of information. Or I could have used a different equation that had A in it, and that would have been okay too. All right, so plugging in, I have delta x equals VI is 0, VF is 61, divided by 2, times my time, which is 24.4 seconds. That's my setup. So 0 plus 61, I don't really need to add 0. Okay, it's just going to be 61 divided by 2 over there. So let's go ahead and figure out what that is. And that's 30.5. And so in my calculator, I'm going to do 30.5 times 24.4. And that should give me my answer. Which I have as 744.2 meters. And again, meters because I'm looking for a displacement, so I should have a distance or displacement unit here. And obviously, if I look at my units over here on the side where I labeled everything, those seconds cancel. All of my velocities were in acceleration was in meters. So that's the unit that you'll be left with when all those other things cancel for your final answer.